Hi everyone, we are going to tackle 2.4. 2.4 only has one little topic in here, but it is a very important start to something that will grow as you go through mathematics. And that is the average rate of change of a function. Okay, so to get an idea of what average rate of change means, we're going to look at a specific example that makes sense to everyday life. So namely, driving a car, driving somewhere. Okay, so here is my picture. This is going to measure our distance, and let's say we started at home and we started traveling, and after an hour we got to this point, and then a little bit later we were here, and after 3 hours we were here, and 4 hours we were here. Okay, one thing I can pull off from the graph, and I'm just telling you that from this graph, this distance from here to here, so going from 1 hour to 4 hours, is 150 miles. So we went 150 miles. We went 150 miles between time t equals 1 hour to t equals 4 hours. Okay, and someone might want to say, well, what was our average speed? On average, how fast were we going? Well, speed or rate is your distance divided by time. How far did you go divided by how long did it take us? So in this particular problem, the distance is going to be that 150 miles that we went. So that change from this distance to this distance. So that 150 miles. And it took us, the time that spanned was from 1 hour to 4 hours, or 4 minus that 1, 3 hours. So we went roughly 150 miles in 3 hours, or we averaged 50 miles per hour. So there is our average rate. So it turned into a rate, miles per hour, and we're averaging 50 miles an hour. Did we go 50 miles an hour all the entire time? No, it wasn't constant. We had some speeding up and slowing down. And when you get into upper level courses in math, we start devising ways to measure. Where are we going faster? Where are we going slower? What does the graph look like when we do that? So that's what calculus is. It's the study of looking at graphs and how things change as we move through our x values. So this is average speed. So what we've done, and I'm going to kind of draw a line in here. Here's our point, and here is our point. We kind of smoothed out our curve. Because if you think, here is the change in these y values over change in the x values. Change in y over change in x. That sounds like slope. Change in y over change in x. And it is a slope. It is the slope of the line connecting these two. So if I had taken and smoothed that out, made a straight line, that gives me the slope from this point to this point, which represents my average speed, or in general, the average rate of change of whatever our function is measuring. So that's exactly what our formula is. So here's the definition. The average rate of change of a function, or of the function. And we'll say y equals f of x. After all, they are the same. They're just different names for the same thing. Between x equaling a to x equaling b, or between x equaling a and x equaling b, or from x equaling a to x equaling b. So you'll see it worded a lot of different ways. Is, think to yourself, change in y. Well, y is your f function. So f of b minus f of a all over change in x, b minus a. I'm going to draw a little picture so this makes more sense to you, kind of keeping our language in line so we can start to remember how all these terms fit together. So a and b are x values, so they're going to be on my x-axis. F is the function, so f of a is here. So this is f of a. So f at a is the y value. F of b is the y value. Okay. If I wanted to label these points, this would be the point. A is your x value. F at a is your y value. Here is my b, f of b. Now the average rate of change is the slope of the line that connects the two. So your change in y's, f of b minus f of a, at y1 minus y2, or y2 minus y1, over x2 minus x1. So our slope formula. All right, let's do an example. Let's say we have a function. Let's say that f of x is equal to 7x cubed plus 8. And we could draw the picture of this graph if we wanted to. And I want to find the average rate of change from x equaling 1 to x equaling 3. So so if we're thinking it's going to be the change in your y's divided by your change in your x's. So I need to know what f of 1 is. I also need my y value at 3. So my y value is at when x is 1, my y value when x is 3. So substituting the 1 in here, so 1 cubed is 1 times 7 is 7, plus my 8 is 15. And here I might need my calculator because I'm going to need to do a little multiplying and adding. I don't want to do it by hand, so I'm going to drag out my calculator. All right, we've got to take 3 and we're going to cube it. So 3 to the third is 27, and I'm going to multiply that by 7, so times 7. And then we're going to add 8. And of course I like to use my calculator. We get 197. Make sure I can read it. 197. Okay, so average rate of change in y, slope of the line, over change in x. So we're going to take this 197 minus 15 over 3 minus 1. F of b minus f of a, b minus a. So 197 minus 15 is 102. No, it's not. 182. And 3 minus 1 is 2. And then dividing, 91. So we get 91, whatever these things represented. So if x represented time, and f, our function, represented gallons drank, this would be 91 gallons per day, hour, whatever. So we'd have our rate, our units on there based on what our y's and our x's were measured in. All right, one more problem. Let's look at a straight line. So let's look at f of x equaling to 7x minus 4. And let's find the average rate of change from x equaling 1 to x equaling 5. Why not? So average rate of change is your change in your y values over the change in the x values. So I need my f of 1 and I need my f of 5. F of 1 will be 7 minus 4, which is 3. F of 5, putting 5 in here, is 35 minus 4. 35 minus 4 is 31. So our average rate of change is your change in your y's, 31 minus 3, over your change in your x's. Make sure you do the subtraction in the same direction. So f of 5 minus f of 1, 5 minus the 1. Up here we did f of 3 minus f of 1, 3 minus 1. So make sure you subtract in the same direction. So 31 minus 3 is 28, divided by 4 is 7. All right. Again, this was a very short section, one little topic to talk about, and it doesn't seem all that difficult, but it is very powerful. It'll lead to something that's a lot more in-depth later in your career.